friends, how are you doing today? You're welcome again to class. Alright, so today we shall do a continuation of our solve problem series. Today we shall start with problem 6. Alright, still on factorization of quadratic expressions. We have a question on the board, actually 3 in 1. It says simplify. We have a bracket a plus b and we have a square. Number 2, a minus b, we have a square. Then number 3, we have a squared minus b squared. Alright, now how do we tackle each and every one of these questions? First of all, understand the expression. That's the first thing to do. Understand the what? The expression. This first expression we have here, we have two terms a and b adding up themselves and both of them squared in a bracket. That means this square is actually supposed to affect the result of both of them being added together. Now again, we are going to see this expression like this. Remember, I've always said that whenever we write expressions, for example x minus y, we do not take them as individual expressions. We assume that they go together, right? We assume that they go together. To understand this very expression which you have in number 1, let's do this. Now if you are having 3 plus 1 all squared, if we are having this, for example, 3 plus 1 all squared, let's attempt to solve this in 2 ways. The first one, do it like this: 3 squared plus 1 squared. That gives what? 3 squared is 6, is what? 9. 1 squared is what? 1. That's 10. Right? Good. But let's solve the second way. The second way we can do it is to solve what's in the bracket first. 3 plus 1 gives what? 4. Now 4 squared, that gives what? 16. You can see that there's a difference in answer. In the first case we had 10, in the second case we had 16. So which of them is correct? Now the one that's correct is actually this one, not this one. The law of indices that says if you have a n raised to the power of n, that means a raised to the power of n and n raised to the power of n means the same thing. That's because both of them are multiplying themselves, so they are multiplying each other, right? That is why when you have two variables like this and they are separated to the same power, do not go ahead and say a squared plus b squared. No, that will be wrong. So now let's further check. Let's check. Now if you do this, 3 plus 1 gives 4, raised to power of 2 gives 16. Then you do 3 squared plus 1 squared, that gives 9 plus 1, that gives 10. So in real life, what does it really mean? 3 plus 1 all squared. We are simply saying, oh, add 3 and 1 and square the answer, right? Now when you add 3 and 1, it gives 4, square the answer, that gives 16. But if you share the interpretation and say, okay, let's go the long way, let's picture it that 3 is raised to the power of 2 like this, and 1 also raised to the power of 2, and then let's do it individually and add the answer. You square that, you get something that is off. You can also do that with the calculator, and you have a bracket 3 plus 1 and you have squared, and then okay, you have 3 plus 1 and you have squared, and you have your answer to be what? 16. Okay, but if you are saying okay, 3 squared plus 1 squared, you have your answer to be what? 10. So you can see it. So that's how to interpret an expression like this. So you don't interpret it as if each of them, but if it was a multiplication sign, you can go ahead and interpret it as if each of them are raised to that power. So let's go ahead. If I want to solve this, how then do we do it? We'll simply say a plus b. That means we are saying a plus b, when you add it, let it be raised to the power of 2. Just like 3 plus 1, when you add it, it gives 4. Let it be raised to the power of 2. That is 4 times 4. So a plus b 1 times another a plus b. That's what this means. Now we'll do this by our multiplication method. We'll say a times a, that gives a squared. We'll say a times b, that gives what? Plus ab. Remember the signs. Then we'll say b times a, remember the signs, plus plus. We have plus ab or plus ba. Then we have b times b, and we have plus b squared. Remember the signs. Now when we solve this out, we have a squared. ab and ba are the same because it's multiplication. You see it, ab and ba, they are the same. It's multiplication, and not just that, their coefficients are just 1 So a plus b and b plus a, that gives what? We add the coefficients plus coefficients, that gives 2. 1 plus 1 2. Then we repeat the ab or ba, which of them you feel like. Then we have b squared. So whenever you have an expression like this, it will always lead you to this. It will always lead you to this. So that's why whenever you factorize a quadratic expression that's like this, now this b squared, if we assume this b is a number, if we assume this b is a number, for example 3 squared will give us a number, so the square will no longer appear. Even if the square appears, whenever you factorize a quadratic expression like this, it will always lead you to something like this. These are the factors. Now using that same knowledge, let's run over to this. So I've explained already now why we can't say a squared minus b squared. That's why we can't say this. We can't interpret this expression as this. It will be very wrong if you do that. So what we rather do is to say a minus b, a minus b. Now we multiply a times a, that gives a squared. A times minus b, that gives minus what? Minus ab. Minus b times a, that gives another minus ab. And minus b times b, that gives what? Plus b squared. Now when we perform our arithmetics, we have a squared minus ab, that's minus 1 minus 1, that gives what? Minus 2ab plus b squared. Hope that's clear. So whenever we factorize an expression like this, it will lead us to this. Now let's come over here. Now we have the expression given to us directly as a squared minus b squared. What should be our answer? What should be our answer? Should we say, okay, a minus b squared? So we can't actually say a minus b all squared. That would be wrong. So what are we actually then supposed to do? What actually are we supposed to do? Okay, now for us to know what our result will be, we're going to try to expand a particular expression, a minus b multiplying a plus b, and let's see what eventually this will lead us to. So we have a times a, that gives what? A squared. We have a times plus b, that gives what? Plus ba. Then we have minus b times a, that gives minus ba. We have minus b times plus b, that gives minus b squared. Eventually b minus a will take off b minus a, and we'll be left with what? A squared minus b squared. Now this tells us that this expression is actually a result of this expansion. So when we cancel out what's at the middle, we'll be left with a squared minus what? Minus b squared. Therefore we can simply assume that this is equal to this. So if we want to expand this, if we want to simplify this, we simply say a minus b multiplied by a plus b. You see it? Now this is what is referred to as difference of two squares. Difference of two squares, which is this, is different from this. This is not difference of two squares. This is not difference of two squares. This is the square of a difference. This is what? Square of what? A difference. And this is square of a sum. Square of a sum, square of a difference. But this is difference of two squares. You can see that we have two squares, two things that are squared. So difference of two squares. This one is an expression which is a difference that is squared. So we say square of a difference. This one is an expression that is a sum, which we eventually square. So we say square of a sum. Hope that's clear. Never again should you make the mistake of assuming this to be difference of two squares. But this is actually the difference of 2 squared. Why? Because you are not permitted to write subtraction, which you have in the bracket, by sharing the powers equally to both of them. It's not permitted in mathematics unless it's a multiplication sign. That's when it is permitted. Alright, so you're going to do this as your classwork. Simplify 1, 2x plus 2 all squared, 2, 2x minus 2 all squared, 3, 2x all squared minus 2 squared. Begin the classwork now, and you get the solution to the classwork later on as you will be told, but make sure you work it out now. Problem 7. Maths is wonderful, right? Let's go. It says factorize 25a squared b squared c squared minus 9d squared. Again, what's the first thing we are going to do? Understand the question. Understand the expression. Now, taking a careful look at this expression, we can see that we have a difference, and then we have some squares on this side and a square on that side, but we still have a number. The coefficient of these variables here is actually not a square, and this one is not a square. So it looks like a difference of 2 squared, right? But then take note, if we are having 2x squared, it's not the same thing as 2x squared. That's one. These are other things you have to understand about variables and algebraic terms. 2x squared not the same as 2x all squared. This 2x all squared means 2 squared x squared, but this one here means 2 raised to the power of 1 x raised to the power of 2. That's what this one means. This one means 2 raised to the power of 1 x raised to the power of 2, but this one means 2 squared x squared, like I've explained in the previous problem. Now that when you are having two terms or two variables, alphabet and variable multiplying each other, we can simply attach the powers to each of them, and I explained the reason for that, right? Now, for that reason, we can't just assume that 25 is going to have a square because they are squared here. Just say, okay, pick the square, just put up everything, put 25 a b c in the bracket and say this. No, this is not the same as this. They are very, very different. So you must be smart. You must be smart to detect and perceive that. Now, for us to know, we can carefully take a look at this. In as much as we are already seeing square on this side and square on that side, we begin to suspect. We are free to suspect that would there be any way I can manipulate this expression so that it can really be a perfect difference of two square expression? And as you begin to suspect, you see that 25 is a perfect square as well as 9. Then you know that this is what they are trying to do. They are trying to see if I have the ability to understand that I can convert this into a perfect difference of two square expression. How? Now, in our solution, we say let's write 25 in its perfect square form, meaning that there are two small numbers that can multiply themselves, the same numbers, to give 25, and that is what 5 times 5. So that gives us 5 squared. That's why we say it's a perfect square. So this is the perfect square form of 25. Then we can now say a squared, b squared, c squared. The perfect square form of 9 is what? 3 times 3, that's 3 squared. We have d squared. At this point, we can then say, let's bring out all the squares. Since we have multiplication, there's no sign in between them, meaning that they are all multiplying themselves. So we can say 5a, b, c all squared. So the square affects all of them. It's like factorizing out the square sign. Minus what? 3d all squared. Now this is a difference of two square expression. And when it's a difference of two square expression like this, the only way to simplify it is to say 5abc minus 3d in a bracket multiplied by what? 5abc plus 3d in another bracket. So this will be the solution to that question. Hope that's clear. Now you're going to do another classwork. The purpose of this classwork which you are given is actually to help you practice just the previous example type which you have just solved, or the previous problem which you have just solved. Now we have just solved the problem and you have the classwork this. So practice it. By doing so, you get used to solving the problems as I solved them, or as the tutor solved them in the previous problem which you watched. So don't joke with the classwork. You are given time to solve the classwork. Work within that frame of time, and if it's not enough, pause the video and finish up before you continue. Now we have problem 8. In problem 8, it says factorize x squared minus y squared plus x plus y all squared. Now, what the first thing you do? Understand the words expression. Now, what does this expression actually mean? X squared minus y squared. Yes, we can say this is a difference of two squared expression, and we have x plus y all squared. All squared. Yeah, we can now say this is a sum. Then the sum is squared. So we can say this sum of this square of a sum, right? Good. Now we have that. So how do we simplify square of a sum, and how do we simplify difference of a two square? Now we can simplify this aspect first, but it will only lead us to having an expression like x squared plus 2xy plus y squared. I think that's even becoming more complex. So how does this actually help us? Then we're having x squared minus y squared, and we're having this, and at the end of the day we'll have a very, very long expression. So we can then ask ourselves, what other way could we go? What if we simplify this first and see if, because the goal of factorization the goal of factorization is to bring out factors, and factors will always be smaller than the original one, right? So what we did just now wasn't factorization, because it led us to a more complex expression as simple quadratic. So we can't say that we have factorized. We can't say that that is a factor of this, but this is only a factor of that. So this x plus y, when we write it like this, x plus y multiplied by x plus y. I hope you know this, what this expression means. When we write it like this becomes a factor of x squared plus 2xy plus y squared. If I wonder how I got this, watch the last two problems we solved. The same thing, right? Good. So now this is not a factor of this, but this is a factor of this. So we can't say we are factorizing this, which is this, to give us this. So that wouldn't make sense. Rather, if we have this is the only thing we can factorize here, right? And even if we are going to factorize this, once it leads us to that x plus y times x plus y, that's where we stop. We should not expand it to lead us to a quadratic expression, because that will no longer be a factor. So now let's see how we can factorize them as simple as they are without going into a quadratic expression. So when we are factorizing this, we'll stop at x plus y times x plus y, and we'll also factorize this. So when we factorize this expression, which is a difference of 2 squared, it leads us towards x minus y multiplied by x plus y. Remember, that's how to factorize the difference of 2 square expression from our previous example. Now, when we come over here, we put our plus sign. Let's factorize this. Factorizing this leads us towards x plus y, x plus y. Is that clear? Good. Now, take note. The previous example we saw, when we said simplify, and we had an expression like this, that's a plus b all squared, and led us to a quadratic expression. We're wondering, is that a simplified answer? The simplified answer will actually stop at a plus b multiplied by a plus b, not just like we have this x plus y multiplied by x plus y. Now, taking it back to the quadratic expression is just actually a theory to help you understand the reason why when you factorize that exact type of quadratic expression leads you to this as the factor. So it's not as if that quadratic expression was the simplified form of that question. I don't know if you understand what I'm trying to say now, right? So don't say, oh, when we are simplifying, it's going to make it more complex. No, you should make it simpler, not more complex, right? Good. Now, coming over here, again, we are having two parts. So if you have been following our series on factorization of quadratic expression, you discover that an expression can be divided into two parts. So we have a sign here, and we're having this. You can split it into two parts like that, and say, okay, is there anything common in this part, and is there anything common with these two parts? So what's common with these two parts? We have x plus y here, and we have x plus y here. So it means x plus y is a factor. It's a common factor of these two parts. So we can simply factorize out x plus y. Hey, dear JAMBITES, what do you think about having a video lesson such that you can always watch it over and over again? Say we solve a problem on differentiation or matrices or algebraic fractions, and you can always watch it over and over again. That would be awesome. If you want that, simply join our online tutorials hub. Yes, you can start for free. Start 0703 641 2479. Make that investment with the device in your hand. have a big bracket, and x plus y cancels out x plus y here, leaving us with what? X minus y. And we have our plus sign. Then when we come over here, x plus y cancels out one of the x plus y, leaving us with the other what? X plus y. Eventually, since there's a plus sign, it means we can open this bracket by multiplying the signs. So plus times plus gives plus. So eventually we have x minus y here. Plus times plus gives plus. Plus times plus again, that's plus x here. Plus times plus y gives what? Plus y. So we can now remove this bracket, since we're now having this other bracket come and a plus sign. So then we write our x plus y, which is our common factor. Now we can say x plus x gives what? 2x. Minus y plus y cancels out. That's the difference. Minus y plus y, I say y minus y. So we have only 2x left. And remember, our factor, which was multiplying what was in the bracket, now we have 2x in the bracket. Our factor will still be outside. That's x plus y multiplied by 2x. So this is the factorized